Good morning and welcome to the North Meck High School Algebra 1 EOC video clips. The topic for today is 1.02/1.03, Formulas and Direct Variation number 4. Now this is not one of the highest weighted items on the Algebra 1 EOC, so I combined the two objectives together. So we have use the simple formula, we also have direct variation problems. Alright, problem number 1, you're given a formula, you need to solve for a letter. Given a formula, you need to solve for a letter. Alright, if I want to solve for t, I need to get t by itself. That means that I need to get the p moved over to the other side, I need to get the 1 moved over, and I need to get rid of r. So if I'm going to solve for t, the first thing I need to do is divide by p. Because p is multiplied, the inverse operation is division. So now I have a over p equals 1 plus rt. I'm still solving for t, so the next thing I'm going to do is subtract 1 because it's added, so I'm going to subtract 1. Now I have a over p minus 1 equals rt. Next, to get rid of r, I'm then going to divide both sides by r so that I have a over p minus 1. All of that divided by r equals my t. And I'm done. Now in some cases I can simplify that, but most of the time your job is just to get rid of everything except that letter. You want to get that letter by itself. So what they're really checking is to see if you understand inverse operations. If you know that in order to get rid of the p, you're going to use division because it's multiplied. In order to get rid of the 1, you're going to subtract 1 because it's added. In order to get rid of the r, in order to get rid of the r, you're going to divide by r so that you're solving for t. Problem number 2, this time we're going to solve for x. So you zero in on your x, and you say to yourself, okay, that means I have to get rid of a and I have to get rid of b. Alright, let me start with a. How do I get rid of a? Since a is divided, I'm going to multiply both sides by a. So that I have z times a equals x minus b. Now I'm still solving for x, so that means that I need to get rid of the minus b. To get rid of it, I'm going to add b to both sides. So that I now have za plus b equals x. And I'm done. That one was a little bit simpler and only took 2 steps to do it, but the concept is still the same. You're solving for a letter. Anytime you have an equation that's made up of all letters, you could be asked to solve for any of those letters. So be prepared to use your inverse operations to get that letter by itself on one side. Alright, that's for your formulas, your formula work. Alright, let's go to 3 and 4, which has to do with direct variation. Alright, problem number 3. Michael earns $123.75 for working 15 hours. How much will he earn for working 40? Alright, I'm going to set this up as a proportion. For 15 hours, he earns $123.75 equals, so this is hours is to money. Hours is to money. As hours, 40, is to money, we don't know, x. So again, hours, see the matching hours up top, the matching money at the bottom. Now, this is back in 6th grade now. All you need to do is cross multiply and divide by 15. 40 times 123.75, and then divide by 15. Alright, so I have 40 times 123.75. Hit enter, and I'm going to divide that by 15. So how much did he earn for working 40 hours? X equals $330. X equals $330. Again, hours is to money as hours is to money. Now the truth is, you could really say either way. You could say money is to hours as money is to hours. You'll have the same proportion, so you just cross multiply and solve as well. Alright, number 4. If P varies directly, alright, varies directly, P equals K. Alright, P varies directly means equals K as the square of Q. So Q squared. And the constant of variation is 6. So now I can say P equals, the constant of variation is 6Q squared. What is P when Q equals 12? So now I have Q. So I have P equals 6 times 12 squared. 6 times 12 squared. So now P is equal to 6 times 12 squared. 6 times 12 squared. Hit equals, and you got 864. So, if P varies directly equals K as the square of Q squared. Now, it could say as the cube of Q, which would be Q raised to the third power. It could say the square root of Q. You would still have P equals K square root Q. And then it says the constant of variation is 6, so this K stands for the constant of variation, so we put the 6 in. What is P when Q equals 12? So we put a 12 in there, and we have 6 times 12 squared, which is here. P equals 864. So varies directly. The P varies directly is equals K as the square of Q, so Q squared. And you just plug that in. Again, I combined both of these because this is one of the items on your EOC that has the lowest weight. You won't have as many of these items, but they are there. And basically, you're given a formula, solve for the letter, use inverse operations, direct variation problems. If you have all three numbers, you can use a proportion to set it up. You can also do direct and get your constant and then work it back through. Same process. And then number 4 is a straight word problem on direct variation, where you set up the formula, plug in the pieces that they give you, and get your answer. All right, on the other board, I have the additional practice to go with it. Number 1 is the same formula as number 1 in the video. You're going to be solving for R this time. So get rid of your P, get rid of your 1, get rid of T. All right, the next problem, same formula, but you're solving for A this time. So what you want to do is multiply by your A and then divide by your Z, and you'll be done. Number 3, same problem about working. Jackie's earning more money, though, I think. $275 for working 5 hours, so definitely a lot more money. And then number 4, if W varies directly as the square root of T, so not the square, but the square root of T, what is the constant of variation when you have the two pieces? So you can plug in what you need and solve for the constant this time. All right, once again, if you complete the additional practice, watch the video so you can complete the additional practice and turn it into your Algebra 1 teacher, you will receive credit. Thank you so much and have a good afternoon.